Awesome. Hi, everyone. My name's Elena Sundro-Gano. I am part of the research advancement practice with Chartis. We're a national healthcare advisory services firm. And I also serve as the national project manager of the ENACT network. So I have the privilege of introducing our afternoon panel on data enclaves. So our panelists are going to run through 4 different programs that are solving very different problems with the use of data enclaves. So to kick us off, we have Yanshan Wang, who is the Vice Chair of Health Informatics at the University of Pittsburgh, and he's going to talk to us about ENACT.
Thank you, Elena, for the introduction. So I'll try to be quick because we only have 60 minutes for the panel. So first, I want to talk about the ENACT enclave use case, which is, we call that ENACT Alpha project, which we try to use the ENACT enclave as a testbed to evaluating the generalizability of AI models. Previous speakers already talked about what is ENACT. So ENACT is basically a federated distributed network across the nation, CTSA hubs that are founded by Enclaves. So the ENACT network covers more than 50 CTSA hubs and have more than 142 million unique patients across the network. And then any investigators from any of the CTSI institution can query the entire network, and the returned results are basically counts of the patients from the network. So the challenge of using ENACT is that you only got a count of the cohort query you send to the entire network, and you won't be able to have the access to the patient level data. And to solve that problem, in the past cycle of the ENACT funding, we created the ENACT Enclave, which is trying to make all the patient level data available for analysis using the AWS platform. So the AWS platform that we create for the Enclave is a secure EC2 instance, and we can use either Windows or Linux operation or as an operating system. And this is a very secure environment, very secure that you cannot even copy paste. That's when we realized that copy paste is such an important function when we do data science there. So the person who have access to the AWS environment from their workstation, cannot download the data from the Enclave, cannot upload the data. You have to contact the managers of the AWS environment that manage from the UC San Diego to upload the data. And also, you don't have internet connection within the Enclave. That's why it is very secure and easy to pass a lot of the regulation and regulation agreement. And all the patients, that the data of those patients uploaded to those enclave are limited to the studies that are approved by the ENACT governance team. And all the patient EHR data follow the I2B2 common data model, because those are all the common data model comes from the ENACT network. And the ENACT ontology harmonizes the data with ONC standard vocabularies, including the ICD code, ICD-10 code for diagnosis, CPT code for the procedures, LOINC code for an ASNORM code. So those are all standardized. And an ENACT site has control over which Enclave study they want to participate, and they want to send those standardized data to the Enclave. And the ENACT governance agreement has updated for the Enclave participation. And right now, we have 4 sites, including Pitt, UCSD, UT, Southwestern, Harvard, MGS, who signed the data use agreement to provide data to ENACT Enclave. So this is basically the ENACT Enclave workflow. So investigator from ENACT site can use the Shrine query to define the cohort, and then the Shrine query will translate it to I2B2 query locally, and then export those query and get a cohort uploaded to the ENACT enclave. So each individual institution, part of the ENACT network, has can submit to RB and the data use agreement just once. And once those agreements are done, investigators from this site can initiate any study and use the enclave. And I2B2 computed model right now is used as default to standardize the data, but those computed model can be exported in either OMOP or PCORI format based on the request. So this use case where we try to do leveraging the ENACT enclave is to evaluate the AI model generalizability. Because as several previous speakers mentioned, the AI model is developed in many institutions. And in most cases, majority cases, the AI model is developed based on a single institutional data. And the problem comes when we try to translate the AI model to another institution, right? How the model probably performed well in the institution that it was trained on, but the performance decreased dramatically when it translates to another institution. Another problem is, all the population is heterogeneous. So different institutions have different populations. And also we have different subpopulations in different institutions. Your model probably perform well in an institution that has most of the population are Caucasian, but in another institution where you have a diverse population across different age groups, ethnicity groups, or even underrepresented groups, you don't know how your model perform. So to solve that problem, we try to use the ENACT enclave because ENACT have access to more than 50 institutions across the nation. We want to leverage all the data available in ENACT to test, to evaluate the AI generalizability. So this is why we initiated this ENACT enclave, ENACT Alpha project based on the ENACT enclave. So we try to use the AI model that built from any institution, and then evaluate the AI model using the current ENACT enclave. Of course, right now we only have 4 institutional data, but this is like a proof of concept. We can use those 4 institutions EHR data to test the generalizability of those AI model. And also after testing the performance, we can aggregate the performance of AI model in general metrics like precision recall FN score, as well as a dashboard of the performance on different subgroups across different risk groups, ethnicity groups, gender groups, and also underrepresented subgroups. So how this alpha works? So first, we have AI model intake. So basically, we for any institution, when we try to reach out to them to share their AI model, sometimes they are okay with sharing the model weights, which is really the model itself, and sometimes they are quite conservative. Maybe they can only share the algorithm, the script that used to train the model. And we also want to collect the model card. Basically, what is, for example, what tool they use to build an AI model? Did they use R to build a model or use Python? And what is parameters of those models? So we want to put together those model cards as well when we try to intake those models. And once those models, we receive the description about the model, we will prepare the data and pull the data from those 4 institutions from the ENACT enclave. And the second step is a logic mapping. The logic mapping is basically that we have to align the model input to the data we have, right? So because those AI model may be built differently, very differently from institution to institution. But our data is the I2B2 combinated model. We have to think about how to map those I2B2 combinated model variables to the feature variables in the model. The third stage is data harmonization. So in data harmonization, we may need to do, I will talk about the detail later. And the stage 4 is the blind execution. And we have to run the model in the secure enclave and collect result. And the stage 5 is fairness evaluation, which is the goal of this entire project, because we want to know the performance of the model in the ENACT cohort, and also in different subgroups of the ENACT cohort. So here I will go through different stages using 3 case studies, and those 3 case studies are it's all published AI models. So each study is the AI model from each study is developed by different institutions within the ENACT network, and we put those studies together and try to evaluate the AI models, in their institutions. So the first study we evaluated is called ADRD prediction model, which is try to predict the Alzheimer's disease and related dementia using the longitudinal EHR data. So this model is trained on UT Health Houston data, and this model is basically a deep neural network model based on the gated recurrent units with decay. So, and also with the attention model. So this model was trained on the OMOM common data model. So we have, when we initiated this case study, we have data use agreement, and actually eventually we have to end up with a material use agreement, because this, what they try to share with us is a model, not really data. So that's why we end up with a material use agreement. And then we collect the model card for their model. For example, what kind of architecture they're using, what kind of feature vector they're using, and what are those features. And actually there are more details about the model card, because this is a deep learning model. We want to know what is the, the training data of the model, what is the description of each feature in this model, what is the model output, and what is the source code. So eventually UT Houston shared the model with us. Also, they shared the Python code that were used to train the model and validate the model with us. So that make the evaluation much easier. So stage 1, basically data preparation, and right now this is a preliminary result. We only put PIT cohort data to the ENACT Enclave, and stage 2, logic mapping. We have to carefully map each model feature back to the I2B2 common data model. And we kind of use LM-based assisted approach, try to help us, because there are, if you take a look at the previous, there are like 173 features. So it's very time consuming to do that manually. So we use the LLM assisted approach to kind of map those feature variables with the I2B2 common data model. And what is very tricky in this model evaluation is the medication, because they use a specific code for the medication, and we have to carefully map those medication to the common data model. And after we map those, we have those basically data translation, translate the I2B2 common data model to the features that are used to train those models, and also data transformation, which is a very important step, because when they train the model, they probably use a one-hot embedding or some other kind of embedding to embed the code instead of using the original code. So we have to do additional step of data transformation to transform the data variables into the features that are used to train the model. So regarding the blind execution, we have the original code to evaluate, for the evaluation. So we leverage those code and run those execution on the ENACT Enclave. This is some preliminary results. So basically, the result shows our, all the evaluation code successfully run on the ENACT Enclave. So we are able to predict the ADRD onset based on the years, different years before the onset index date of ADRD using PIT data on the UT Health model. The second study, let me go this quickly. The second study is ICU modality prediction model. So this model is was also published. This model was developed using the Mimic 3 data. they try to predict ICU modality at in hospitals 30 days, 60 days, 90 days, and 1 year before it really happened. So this model is basically a deep learning, deep neural network model, and also used mimics rate data. So we did the same thing for this model. We kind of collect the model card, like the architecture of the model, the feature vector of the model, and input, output of the model. But one challenge we are facing right now is that we, in the ENACT enclave, we have a lot of data for the cohort, but we have very little data on inpatient, in the emergency department. But this model is trained specifically on mimic data, which is all emergency department data. So that's why some analysis is still ongoing. We don't have a result yet. For the third case study is a model trained from UT Southwestern, iron deficiency anemia. So this IDA is a very common health problem, and they try to build a regression model, classifier, using the labs data to predict IDA onset. So we similarly, this model is we collect the model card for this model, like the architecture of the model, the feature vector of the model, and also we ask the specific site to share the model with us. But one challenge we are facing right now is, they, instead of sharing the model, they can only share the Python script that we used to train the model, because the site has some concern about sharing model weight that we can do the re-engineering to, kind of interpret the feature. So that's why for this evaluation, we only have the Python script. And we use the Python script and use the data in ENACT Enclave to train the model from scratch and also evaluate that model. Although we don't have the model weight from the site, but we can still leverage the same approach and validate their approach using ENACT Enclave. And this is some preliminary IDA prediction results. We are able to get a UC like a 75%, which is of course lower than their AUC, where which they was validated using their own institutional data. And what interestingly here is we actually measure the fairness on this model using different gender groups, different risk groups, ethnicity groups, and also different groups with different insurance. So the goal here is to show the pipeline of evaluating any AI model using ENACT Enclave. It doesn't matter the site have the model weight, that they want to share us and evaluate their model, or they only have the approach or Python script or R script they use to train the model. We can still use the script to train the model and validate their approach using ENACT Enclave. And thank you. I'll just stop here.